Good morning, students. Today we'll be starting with the different oxides of nitrogen. Last time we have discussed about the periodic functions, and we have also spoken about with respect to nitrogen its preparation as well as its compound, that is ammonia's preparation and its structure with respect to chemical bonding. Now today we're going to talk about the different oxides of nitrogen. Now rather than the slide, I'll explain you in a little better way with tricks so that anytime if you have to draw the resonating structures or the Lewis structure, it becomes easy for you. Let's start, people. Now nitrogen we have discussed in the oxidation state that the oxidation states will vary from something like -3 to +5 because nitrogen, depending upon oxygen how it combines, shows a variety of oxidation states. Now let's talk with the first part over there. First of all, in oxides, normally oxygen oxidation state we all know is always -2, except for peroxide. So here what we're going to talk is only its oxides. There'll be no peroxide bond. So oxygen oxidation state is always -2. So let's start now. First part, the first oxide over here, what I'm explaining, that oxide is what we call as N2O. That's what we call as nitrous oxide. We all know this is nothing but laughing gas which produces hysteria. Okay. N2O में oxygen oxidation state, people, if I have to put up over here, oxygen is -2, nitrogen over here, that's +1 into 2. Okay. So oxidation state of nitrogen is +1. That's one. It's a colorless gas. Let's talk about now framing the structure with respect to it. Okay, how do I write the structure with respect to its Lewis formula and its resonance part? Let's start. First, nitrogen. How many electrons in the outermost shell, people? Basically 5, because nitrogen atomic number is 7. So 2, 5. So there'll be 5 electrons. So 5 into 2 plus oxygen atomic number 8, 2, 6. So 6 electrons in the outermost shell. So 5 into 2, 10 plus 6. So total we have to set 16 electrons. Okay. Now next, total how many atoms, people? 2 nitrogen and 1 oxygen. So 3 atoms. So to have a complete octet, 3 into 8. Number of electrons, 24. So 24 is what is the total electrons what would be required. Now how do we do? What is the catch in the formula? The catch in the formula goes like this. 24 minus 16. All right, so that's going to be 8. This you divide by 2. That comes as 4. So between N2O, there has to be 4 bonds. Now what we'll do is we will write the Lewis structure as well as the resonance part. Please observe, everybody. Okay. So N2O. So first of all, 3 atoms of nitrogen. 1, 2, and a O. Okay. Let's start now. First part to say 4 bonds. So let there be a double bond here. Let there be a double bond here. 4 bonds are done. Now we will try to show the remaining electrons. Okay. Oxygen, as per the Hund's rule, people. When we write the electrons 2, 6, p subshell has got 3 orbitals. So if I have over there nothing but what we can call as, if I have to put in the p orbitals, that is 1s2, 2s2, 2p4. So 3 will go in parallel, 1 will go anti-parallel. So oxygen has 2 unpaired electrons, so it forms 2 bonds, and it has got 2 lone pairs, that is in its 2s2 and 2px2. So the 2 lone pairs is what I'm showing here. Please see the dots, people, carefully. So these are the lone pairs. So that's done. Now come to this nitrogen between. There are 4 bonds. So 4 into 2, 8. This octet is complete. Come on this. 2 and 2, 4. So 5, 6, 7, 8. Okay. Now check. Have we got over this requirement of 16 electrons, people? Just see this part, everybody. Have we got the requirement of 16? 2, now I'm counting from the left of nitrogen. Just see, please. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's done. Most important now, let's see the charges. Oxygen at 6 electrons. So 1, 2, 3, 4, 5, 6. So this right hand side oxygen, 6 electrons are there of oxygen, so no charge. This nitrogen in between, 1, 2, 3, 4. So it's 1, it had 5 electrons, 1 is gone. So this between nitrogen develops a plus charge. Come on the left hand side one, 2, 4, 5, 6. It had 5, it has gained 1 more. So this acquires a negative charge. Everybody clear with respect to this now? Okay. Now we will see its resembling structure. Let's see how the resembling structure looks like. Now in the resembling structure, people, if I have to make, how will this be? This will be N, N, and this will be O. Now instead of four bonds is what we have to put, okay, as this was discussed. Now how to put the four bonds? We'll put a triple bond here and we'll put a single bond here. So four bonds are done. Now let's put the remaining electrons. We have to set 16 electrons, okay, everybody? So now we have over here 6. So here there will be, so in this case 6 plus this will be 2. So that's going to be 8. On this nitrogen, 3 plus 1, 4, 8 done. This is 1, 2 done. So this will have 6 more electrons. So the 6 more electrons over here, that's what is the part. Okay. Let's check, is the octet completed? Always remember, whenever oxygen has a double bond, then the lone pairs will be two pairs of lone pair, means 4 electrons. And whenever there's a single bond to oxygen, it will have 3 lone pairs of electrons. That's total 6 electrons. So let's count now. 16, triple bond, so 6 plus single bond, so 6 plus 2, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's see the charges back, how it is. On this people, 3 plus 2, 5. So this nitrogen on the extreme left, over here, that's complete. Center nitrogen, 3 plus 1, 4. So 1 electron is lost. It had 5, right? So 3 and 1, 4. So 1 is lost. So this acquires a positive charge. And on this oxygen, 2, 4, 6, and 1 extra has come. So 7. It had 6. So this acquires a negative charge. Everybody clear? This is the way how you draw the structures. Is this clear? And understand the logic of it. Okay? This is the first one, N2O. Going to the next one, people, what we have now, we'll be talking about nothing but the second one, that is what we have as nothing but NO, what we also call as nitric oxide. Okay, NO. Let's do NO first. NO total people electrons will be how much? Nitrogen outermost shell 2,5, so 5 plus oxygen 2,6, so 5 plus 6, 11 electrons. Now whenever we have odd number, meaning remember we have to subtract 1, because with odd numbers we will get a fraction. So if to subtract 1 means there is an unpaired electron which will be present, which will explain its paramagnetic behavior. Okay, so this is total 11 electrons. Let's start now. How do we do this? How many atoms are there? 1 nitrogen, 1 oxygen, so that's 2. So 2 into 8, so that's going to be 16. We have 11, so 16 minus 11, so that's going to be 5. And as I told you, if it is odd, subtract one more, that's the paramagnetic part. So that's 4 divided by 2, which is 2. So between N and O, now there are only 2 bonds. Let's do the math now. So we have N, we have O. Okay, everybody? Now there are 2 bonds, so I'll just put 2 bonds. Let's complete the remaining octets over here. Now to complete the remaining octets, what do we say over here? On this nitrogen, 2 are formed. So this will have basically over here on this 2 are formed. So this oxygen, I will show the 2 lone pairs. So that's done. Now on this nitrogen people, there were 5. So it's already over here, nothing but 2 and 2, 4 over there. Is it clear? That is what is the set part over there. So in this case for nitrogen, when I'm talking, what exactly will be the logic over there? The logic will be over here. Right now, if I'm putting it, then this will have over there nothing but 1 electron to put up over here. So this will have 1 unpaired electron. Now if you count 4, 5, 6, 7, 8, 9 and a lone pair on nitrogen. Got everybody? So that's the structure what we have. Nitrogen 1 lone pair. So everywhere if you observe, it's done now. So 2, 4, 5, 6, 7, 8. So the oxygen complete. On this nitrogen, we are having over there 1, 2, 3, 4 and 1 unpaired electron. So that's NO. If anybody remembers, we had in the drawbacks of the octet rule. What was the drawback? It couldn't explain how structure of NO is stable. Now, let me show you the resonance part. Observe this. Observe very well, okay? Now the first structure we have, that's between N and O, okay? Bond order we have over here, number of bonds has to be 2. So first I put 2 bonds over there. Now what I do, now I just shift this part in the sense 1 electron from this oxygen can move on to this nitrogen part. So I can have a structure which will be like this. Nitrogen will have 2 lone pairs. Okay, so the octet is complete 2, 2, 4, 5, 6, 7, 8. Here, this oxygen will have 1 lone pair and 1 unpaired electron. Okay, so the unpaired electron has shift from nitrogen to oxygen. Let's put the charges. 2, 4 and 1, 5. It had 6, so it has lost 1. So this acquires a positive charge. On this nitrogen, if you observe 1, 2, 3, 4, 5, 6, it was 2, comma 5, it had 5. I'm just counting nitrogen, okay? So 2, 4, 5, 6. So it has gained 1. So this will have a negative charge. So this is one probability. We can have one more arrangement. What we can try to put over there, if you have to see, that will be somewhat like this. Again, between N and O. Now again, as we have, number of bonds has to be 2, so I put 2 bonds over here. That's done. Now on this nitrogen, I will have only one lone pair. That's it. So 2 this way. And on this oxygen, to have a complete octet part, I can show in this manner. It has got one unpaired electron because that 11 is there. No? So one unpaired is always there. Now you count, it's 11. 2, 4, 5, 6, 7, 8, 9, 10, 11. Everywhere in all the structures left 11 electrons. And now total for oxygen 2, 4, 5, 6, 7. So it has gained 1. So now this acquires a negative charge. And this nitrogen is 1, 2, 3, 4. It has lost 1. So it acquires a positive charge. So this is the structure of NO. Now NO, people, just an idea to you. Now in the previous, NO is a neutral oxide. Now what's the definition of a neutral oxide? An oxide that neither combines with an acid nor with a base, then that's called a neutral oxide. Examples to give, one is NO itself, other one is carbon monoxide. So carbon monoxide, if I tell you, then that is also an example of neutral oxide, as well as N2O, the one we saw on the previous slide. N2O, nitrous oxide, is also a neutral oxide. So both NO and N2O are neutral oxides and both are colorless gases. So this is one part what we have. Okay. Now we go after NO, we go to the next concept. Now this concept, people, is basically of N2O3. So look at the compound what I have. The compound what we call that's N2O3. That's what we call as dinitrogen trioxide. Once again, people, in N2O, nitrogen was +1. In NO, nitrogen was +2. Now in N2O3, nitrogen ka state, if you see, each nitrogen is +3 state, because +3 into 2 +6. Oxygen will be -2 into 3. So that's going to be -6. Clear? That's the part. Now, this compound, people, N2O3, if I have to put, let's do the same math how we did again. Nitrogen has 5 electrons, so it's going to be basically 5, we have, one second, we will have 5 into 2 plus oxygen is 6, so that's going to be 6 into 3. So it'll be 18 plus 10. So 18 plus 10, total we have is 28 electrons. Okay, so as there are 28 electrons, we have total 28 electrons to set over there. And here, people, if you observe, let's talk about the number of atoms we have. We have total 2 plus 3, 5 atoms. So this will be 5 into 8 to have a complete octet. So that's gonna be 40. So we will say 40 minus 28. So this comes as over here nothing but 12, which I divide by 2, then the total bonds that can be present is 6 bonds can be present. Now let's understand and see how it is. So nitrogen is in +3. Now in this, if there are 6 bonds, the arrangement will be nitrogen, nitrogen, so that's N2. I will show one oxygen here, one oxygen over here, and I can show one oxygen here also. Now let's start putting 6 bonds over there. So 6 bonds if I put, so this will be 2, then this can be 4, 5, and 1, 6 bonds. Now as there are 6 here, so the double bond, so oxygen will have 2 lone pairs. Here also a double bond, so oxygen will have 2 lone pairs. Here single one, so oxygen will have 6 lone pairs. 6 lone pair nahi, 6 electrons, so 3 lone pairs, sorry. So total, everybody, now count. Have we got back our 28 electrons? Yes. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, 24, 25, 26, 27, 28. All done, people? So we are done with the 28 electrons? Yes. Now in this category, let's put the charges. Here, people, 2, here 8 done. On this nitrogen, if I have to put, then this nitrogen will have a lone pair over here. So here in this lone pair, if I'm putting it over there, so 1, 2, 3, this part is also done. So 3 bonds, 6 plus 2, 8. On this nitrogen now, if you observe, it has got total how many bonds over there if you observe? It has got 2, 4, 5, and over here. So this nitrogen over here is basically donated its lone pair. So in this case, this nitrogen develops a positive charge because its electrons have become less, 1, 2, 3, 4 only. So one electron is less. So this nitrogen has a positive charge. Come to that oxygen, it has 3 lone pairs, so 6, and one of the single bonds, 7. So it has one extra. So this acquires a negative charge. And over here, that is stable. Now, with respect to this, we can have another resembling structure, where that resembling structure, if I have to tell you with respect to N2O3, will be now what will happen, people? This will swap. This double bond over here and the single bond will swap. I will show you what exactly I'm talking. You have N, you have N, you have a O, you have a O, and you have a O here also. So now the swap will be only between these two. What was a double bond here down will become a single bond, and this was single bond becomes a double bond. And this remains the same as a double bond only with a single bond. So this, if I have to put, this has the complete octet part. Over here now, this will acquire 4 electrons, and this will now have 3 lone pairs because single bond. So please remember, oxygen with double bond, 2 lone pairs, single bond, 3 lone pairs. And the charges practically remain on this nitrogen. Yes, it has got 1, 2, 3, 4. So this acquires a positive charge. And now this oxygen acquires a negative charge. So that's what we have as N2O3. N2O3 is nothing but over here, if I have to say, that's dinitrogen trioxide. That's a blue solid and it is an acidic oxide. Acidic oxide, oxide that combines with water to form an acid, or it combines with a base to give salt and water. That's one. So this is N2O3. That's an acidic oxide. Then next, people, after N2O3, the next oxide we have, that's what we call as the NO2. That's nitrogen dioxide. I hope everybody knows this. NO2, that's nothing but nitrogen dioxide. When nitrogen ka oxidation state, if I have to put, that's going to be +4. That's its oxidation state because this oxygen is -2 into 2. Now this, people, NO2, it's a brown gas what we have, and it's an acidic oxide. Now the concept of brown gas, actually it's a deep red orange gas, but when this gas is coming out, it reacts with the aerosols. People, I hope everybody remembers surface chemistry. We have done aerosols. That's basically liquid in gas over there or solid in gas. It reacts with the aerosols and it forms red brown color, which is of smog. I hope everybody knows smog, smoke plus fog, what we had. Okay, that's why the color we call it as nothing but a brown gas or a reddish brown gas. Now let's talk about NO2 over here. With respect to NO2, if I have to frame how this will be. Okay, first of all, NO2 oxygen status +4, that's a brown gas. Let's start now. Nitrogen outermost we have 2, 5, so 5 plus oxygen is over here 2, 6, so 6 plus 6 into 2, so that's going to be 12. So total electrons 17. Once again, everybody, 17 electrons means, again to tell you, we have one odd electron. So now 3 atoms, 1 nitrogen and 2, so totally 3 into 8. Total requirement 24. So we have this as 24 minus 17. So this comes as 7. I will subtract 1. So that will be basically 6 by 2. That will be 3. Okay. So basically there are 3 bonds between the NO2. Okay. Let's start framing now and let's see how we are able to get the structures. So with respect to the NO2 part, we will have the arrangement like this. I have a nitrogen. I have an oxygen down here. I have an oxygen down here. Now let's start. We need 3 bonds. Same, people, what we did earlier, a double bond and a single bond. Done. So double bond matlab how many lone pairs? 2 lone pairs. Single bond matlab how many lone pairs? 3 lone pairs. This is a basic thumb rule what everybody should keep in mind. Double bond, oxygen, 2 lone pairs. Single bond, 3. Now come on, this nitrogen over here, if I have to put up over here, with respect to the nitrogen, if I have to talk with respect to NO2, what will happen? It has got over here 2. So there is 1 electron which will remain unpaired in case of NO2 now. Now check, have we got back our 17? Yes. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 1 unpaired. That's going to be 17. Now let's talk about the charges over there. Nitrogen how many electrons? 1, 2, 3, 4. So nitrogen is short of 1. So this nitrogen acquires a positive charge. Here 1, 2, 3, 4, 5, 6. So this oxygen is all 6. This oxygen 1, 2, 3, 4, 5, 1, 7. So this is with a negative charge. Now talking about its resembling structure, it will just swap. It's very easy to understand. N, I would advise students just practice it the way I'm showing you. Once you practice, you will easily get it. It's a very easy and a shortcut concept to make it. Okay. Now what we'll do is just change the bonds. What was double becomes single. Whereas double is this clear? That becomes a single. So this becomes a double bond now. Now in this double, so this is gonna have over here two lone pairs. This will again have six electrons, everybody. So six electrons. Now people, with respect to the nitrogen, if I have to say now, unpaired electron one will be there on nitrogen over here, what we see. So that explains its paramagnetic behavior. Now count the electrons total. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 we have got back. Now with respect to this 17, now the charge 1, 2, 3, 4. So this nitrogen now has a positive charge. And now this is complete. Here there are 6 and 1, 7. So this acquires a negative charge. So this is your molecule, that's NO2. That's an angular shaped geometry what we have. All right. And this NO2 is an acidic oxide. So reacts with water to give an acid, or with a base it will give salt and water. That's one. Then moving next people, after NO2, the next one we have, that's what we call as N2O4. Listen to this name. The name has the answer, and a very easy and a shortcut way to remember. N2O4 is a dimer of NO2. 2 moles of NO2 will combine. Now, if two NO2 will combine, both had 1, 1, we just now discussed. NO2 had an unpaired electron. So if there are two NO2 with 1, 1 unpaired electron, there will be a new NN bond, and the structure will be exactly the same as of N2O4. Got everybody? Still, I will explain in the normal classical way. 2 comma 5, so it's basically 5 into 2 plus oxygen is 2 comma 6, so 6, so 6 into 4, so that'll be 24 plus 10, so that's total 34. 4 plus 2, 6 atoms to have a complete octet. 6 into 8, that's 48. Now 48, so if I do 48 minus 34, so that's going to be over there 14. Divide by 2, so that's gonna be 7. So there will be totally 7 bonds. Let's start as I just discussed. There'll be a N single bond N. Okay, I said a new bond form because of the two unpaired electrons. So NO2 was diamagnetic. This will become, NO2 was paramagnetic because of one unpaired electron. N2O4 will become diamagnetic. Now people, the same way, I will show over here a double bond with this one oxygen and a single bond with one oxygen. And over here also I will show a double bond and I will show a single bond here. Let's put the charges now quickly. Two are there, so I have always told you two lone pairs. Single means this will have three lone pairs. Again a double, so two lone pairs, and a single, so this will have three lone pairs. Okay, now let's put the charges. So 2, 4, 5, 6 done. So this will be 6 plus 1, 7. So this oxygen acquires a negative charge because it has one more. On this nitrogen, 1, 2, 3, 4 over here. So this nitrogen over here acquires 4 means 2, 5. So 1 is gone. So plus. On this nitrogen, 1, 2, 3, 4. So this also acquires a plus charge. Here double bond, no charge. And here again a negative charge. And we will also have what we call as its resembling structure. Similar way, people. So I'll have N single bond N. This will the double bonds will become single and single will become double. So this becomes a single bond. That becomes a double bond O. And over here also this was single. So this becomes a double bond O. And this becomes a single bond O. So if I have to put single bond, means again going back to the same thing, three lone pairs. Double bond means there will be two lone pairs. Again a single bond, so that's gonna be three lone pairs. And a double bond means only two lone pairs. Again the issue, if you see, wherever there are three lone pairs, that will be with a negative charge. This also will be with a negative charge, and the two nitrogen will be with a positive charge. So this is N2O4, that's dinitrogen tetroxide, where oxidation state of each nitrogen is +4. It's a colorless solid. Is this clear? Or sometimes it's also in a liquid state. It's an acidic oxide over here of nitrogen. That's one. So that's N2O4. And now going on to the last one, that's what we call as N2O5. Now N2O5, when I'm talking, that's what we call as dinitrogen pentoxide. Okay. So in this, what we'll have, people, what will be so great about it? In the earlier one, we had a NN bond. Here we'll have a NON bond. That is the logic what you have to keep in mind. Nitrogen oxidation state plus 5. Okay, and N2O5 is also an acidic oxide. Now once again, N2O5, let's do the maths again. So this is going to be 5 into 2, so that's 10. Each oxygen is 6, so 6 into 5. So this we will have over here as 10 plus 30, so that's going to be 40 electrons to set. Now to have a complete octet, 5 and 2, 7 atoms. So 7 into 8, total there can be 56. So 56 minus 40. So that's going to be over here nothing but 16. And this I divide by 2. So number of bonds should be technically 8. So let's make it now. How there can be 8 electrons over here, or how can there be 8 bonds between them? As I said, a new NON bond will be formed. So first I write the structures, NON, and then people the same way. One double, one single, one double, and then one single. Check 8 bonds. 2, 3, 4, 5, 6, 7, 8. Rest story very easy. Double bond means 2 lone pairs. Single bond, matlab this will have 3 lone pairs. On this 2 bonds, so oxygen forming 2 bonds, matlab 2 lone pairs. So all you do is that. Single bond, oxygen will be with 3 lone pairs. Okay. Now in this case, again the charge part, whatever is negative, 6 are there, so this is with a negative charge. This is 6, so this is also with a negative charge. On this nitrogen 4, so this nitrogen is plus, and here also this nitrogen is plus. And now if I have to give its resembling structure, similar manner, people, exactly the same, only the double will become single and single will become double over here. So this will be again NON. Now that was a double bond, that becomes single. This becomes a double bond O. That was double, so that becomes a single, and then down we go a double bond O that way. Now let's put the electrons again single. Matlab we have 6, again double, so only 2 lone pairs. 2 bonds on nitrogen, on oxygen, sorry, so 2 lone pairs. Single bond, so there will be 3 lone pairs. And again a double bond, so there will be only 2 lone pairs. That's done. And same way the charge part, where I have 6, so 6 plus 1, 7, so that's a negative charge. This is also 6 plus 1, 7, so negative, and each nitrogen will be with a plus part. So that's N2O5, what we call as it's a colorless solid. Oxidation state of nitrogen is plus 5, and it is also an acidic oxide. All right, so these are the ones what we call as the different oxides. N2O, nitrous oxide, NO, nitric oxide, N2O3, dinitrogen trioxide, NO2, nitrogen dioxide, N2O4, dinitrogen tetroxide, that's a dimer of NO2, and N2O5, that's dinitrogen tetroxide. Okay, clear everybody? All right, thank you.